Hello, in this session, let us discuss about what is process control block under process management of operating system. We already discussed what is process. A process is an active entity, that is a program in execution. So we already discussed while a program in execution, what are the components to be available in memory. Now, in addition to that, how OS will maintain the information about the process. That is what we are going to discuss. So here, each process is represented in the OS by a process called PCB. It is like a collection of data that gives a more detailed information about the entire process. It is otherwise called as task control block. So PCB is nothing but a data structure that contains the information about the process. So it contains many pieces of information associated with specific process. So for each process, there is a separate PCB is there. Let us see what is inside a PCB. And this is the structure of a PCB. Mainly it has a process state, process number, program counter, registers, memory limits, list of open files, and few other parameters. And process state. In last session, we discussed that a process may be in any one of the five states, namely new state, ready state, running state, waiting or blocking state, and terminated state. So the process state, this indicates what is the current state of the process, either it is a ready state or it is a running state like that. Next, the process number. It is nothing but process ID. We know that for each newly created process, there is one unique identifier that's called PID, process ID. Then we have the program counter. We already know what is the use of program counter. If I am executing a set of instructions, if currently I am executing the third line, the PC will always point to the next instruction to be executed. So once I am executing one line to the next line, the PC will keep update to the location of the next instruction to be executed. So that is the program counter. The next one is the CPU registers. So we already know that registers are the small and fastest accessible memory space that is available inside the CPU core. So here the CPU register, it contains the contents of all process centric registers. For execution of this process, what is the register content at that instance that is available in the registers? And also it has the CPU scheduling information. What are the priority and the scheduling queue pointers? In the next session, we'll discuss about scheduling queue. So what is my priority? Am I a low priority process? Am I a high priority process? Like those information are available here. And in addition to that, we have memory management information. How much memory is allocated to the process? Is there any memory deficiency? What are the memory space? How much space is left? Like that, am I the memory management information? In addition to that, accounting information. How much time this process is used? What are the clock time it elapsed? What are the time limits? So to assess the performance of a process, to know the response time, to know the throughput, we need to know about how far the process has the waiting time, how long I am waiting to get served, while execution, how much time it takes, how much time it takes for me to complete the entire process. That we'll discuss in detail about the CPU scheduling, but those information are maintained here in the accounting information. In addition to that, IO status information. For example, for this process, I am having a Word document. This Word document, I am going to use a printer for printing. So this is an IO. I have an output file to print. So this I have an IO device associated with my process P. P1 is associated with printer. So I need to keep track of what are the IO devices I am having, what are the list of open files, what are the status of input output devices. These are all keep track under the PCB. So in total, the PCB is the data structure, is a collection of information specific to each process. It is maintained by every OS. It is process centric. So it contains data like process state, program counter, CPU register, CPU scheduling information, memory management information, accounting information, and IO status information. Thank you.